I'll start now, though. Great, now we're recording. Okay. So, these are saying the same thing, okay? This, all sailors who have rented all boats at least once. Okay, so there's some, like, shipping yard. They have a bunch of boats for rent, and they just want a list of the sailors who have rented every single boat at least one time. Okay? That's what I've just highlighted in blue. Now, this is the exact same query, the exact same results, just phrased differently, which is, give me all of those sailors except those who could have rented, where there exists a boat that they didn't rent. So where there's a boat that they hadn't rented before, and they still haven't rented it. So if there's a boat that somebody hasn't rented yet, then remove them from the list of people that you're going to return to me. Okay, so I want everybody except those that could have rented a boat but didn't. So these are identical queries. Logically, anything that is true for one would be true for the other. Okay, that's what I mean that they're... but here, return all sailors who have rented all boats. Here you go, all boats. There's our for all. Here, we have a set difference. And here is, here's our exists. Here. They could have rented a boat. They could have rented a boat. That means that there exists a boat that they haven't rented yet. I mean, you could rephrase this in different ways in English and whatever. Logically, the point is that now we've changed this into a set difference, and then here's a there exists statement. And it's this query, the one in yellow that's highlighted, that's the form that relational databases understand. It seems odd that this is the case. It seems maybe wasteful, or why not make it understand it phrased both ways, or whatever. It just doesn't. The point of this section is to get that across and to help you navigate how to then phrase things in a way that can be understood. Maybe if you're having trouble writing the query, you just need to look at it in a different way. Look at it from the opposite side. So the first not does a set difference, correct. And the second changes the query from for all to there exists, correct. Yes. That is the result of applying these two negations. And the result should be the same. I mean, logically, if you have a query and then you negate it once and then twice, nothing has changed. This is a very more abstract math way of understanding it. I think this is good. I like this as a tool. You can also think of it as I don't know, like a bouncer or something. Like let's say here, here we have a party at 10. We have a party at 10 p.m. with the cool kids. Okay, now there's two ways that this could go. The results are the same. Okay, one, here, one. Empty room until 9. 2, bouncer lets cool people in. Okay, so here we have our little bouncer guy, and only the cool kids are going to be let in. Outside, there's going to be some cool kids and then some not cool kids. And the job of the bouncer is to check IDs, and if you're cool, you're let in the room. Okay? Now at 10 p.m., we look at the room and, until, yeah, fine. We look at the room at 10, and we only see cool kids. Way number 2 is one, let's see, room is open to all, and bouncer kicks people out at 9. All non-cool kids kicked out. So in this scenario, at some point, this is like a room that's open to all, at whatever point. But now it's getting late. It's like 9 o'clock. And now we have a little bouncer indoors. Who's cooler than that? Okay. Who goes around and checks everybody in the room. And if you're not cool, he kicks you out. So this would get kicked out, that would get kicked out, and kicked out. Okay? Now it's 10 o'clock. We look in the room, and it's only cool kids. Okay? So this is the exact same logic. Either you can let things come in and check them at the door, or you let everything in and then you remove the undesirables. The result of which is that you have this room with only people that have things that you want. Okay. Depending on the query, you have to do one or the other for SQL. Find the names of all sailors who rented a boat. Yeah, it's different. It should be the sailors. Because it's yeah. I'll try to make a clarification for this. It should be the list of sailors who have rented all boats at least once. What does each purple line point to? I was just trying to say that here, this first knot is going to correspond to a set difference here. And the second knot is going to be responsible for making a there exists statement. So again, this is saying on the left something where it's true for every single thing, like a sailor renting a boat. For every boat, the sailor has rented it at least once. That's difficult to write a query for. You can try it. In fact, you should try it. I firmly believe you'll fail, but who knows? Try it anyway and see. So instead, we're going to say, return to me all of the sailors except those where there exists a boat that they did not rent. So all sailors except those where there exists a boat they didn't rent. Do you put parentheses around? Yeah, I mean, I'm guessing if there would be a parentheses around that. It's one set minus another set. Where? Was a question up here earlier. My answer is that for the question is that it's longer because it isn't using a select statement. Yeah, no, that's not relevant. Yeah. To the student who asked me if this is more complicated because there's no select statement, and no, that's not the reason. Are you rephrasing to avoid duplicates? Again, no. I'm rephrasing in order to make it where there's only where the first quantifier that you see is a there exists. Okay, I'm not seeing it, but now I remembered a question that I saw asked earlier. I'll get to that now, which is as far as these set differences. There's two set differences. Okay, we've explained the first one. Okay, that is here. You know, get all of the sailors in the room. Okay, that's now we're in this world, okay? So we're going to get everybody in the room, all of the sailors, and then we're going to define the rules to give to the bouncer, so then the bouncer can go and kick people out. So right now, here, this part is everybody in the room. Okay? It's before 9 o'clock. Now 9 o'clock hits, and the bouncer is going to be coming around and kicking people out. Now, this first part this is projecting the names of the sailors. So we have the names of all of the sailors. The second one, now we have the names of all of the boats. And now when we cross multiply them, we're figuring out all of the different pairings, all of the different sailor name boat combinations, all of the possible ones. Okay? Now, from this list of all sailor boat pairs, we're going to remove here the actual ones. Okay? Let's imagine 2 sailors and 100 boats. One of these sailors has rented every single boat. The other has not. He's only rented like 1 boat. You know? Okay. So then in the purple circle, this would be the names of 2 sailors, each matched with 100 boats. Right? Those are all of the possible pairings. There's 2 sailors and 100 boats. This sailor could match up to all of the boats in this way. This sailor could match up to all of the boats in this way. And now you have, 200 pairs. Of those, now you're going to subtract the sailors, which is the sailors who have actually rented boats. Now, for the first sailor who has rented every single boat, there's an entry for every single time he rented that boat. And so when you take away his rentals from the list, if you take away his rentals, it's the yellow. From the purple, which is the list of possible rentals, then everything will be accounted for, everything will get deleted, right? Because this sailor and the yellow in the ledger of people who have actually rented at times, we've found a corresponding entry into all of the possible ways that people could. And now what would be left here would be a list of 1 sailor with 99 boats that he didn't rent. He could have, but he didn't. If he did, then we would have had a record of it in this sailors list. But because we didn't have a record on it, then in this blue box, therefore he's on our list of people who could have rented a boat but didn't. Okay. I don't know how much more to go into it without sounding like a crazy person, but hopefully that explains it, okay? So this is the list of all of the sailors. This is the list of all of the sailors who are missing a boat rental record. After the set difference, do you get the names of all sailors who have not rented a boat? Yes. Something like that. Yes. So here. For this set difference, that is this one, for this set difference, you get the names of sailors who have not rented a boat. Yeah, there exists a boat they have not rented. That's where their exists comes in. So instead of people who have rented all boats. We're asking for people where there exists a boat that they have not rented. And these are complementary sets. Okay. Boy. Okay. Any other questions about that? I guess. Or anything else with relational algebra? So the reason why it's complicated is because of what works with the queries and what doesn't. Yes. Yeah. I mean, sometimes queries can get very long. In fact, I might give one of these as some kind of... I'll have to think about it. But I mean, even these queries that we're working with are very short queries. I mean, it's easy for queries to really kind of expand in size. And the reasoning behind this question is to explain why that is. Why isn't it that, I mean, if you see a query and it looks gigantic, like, and you think, why don't we just make it simpler? Like, isn't there a way to like write it in fewer lines? It's like gigantic. Sometimes yes, other times no. This is a case where no, you can't write it any shorter. So if you're thinking about trying to optimize queries and things like this, knowing, when it's just you're stuck at this length of a query. But I mind going over what's inside of the parentheses after the first set difference once more. Sure. So, piece by piece, okay? And also algebra, okay? So here we're looking inside of some parentheses here. And if I look at these operations, I can just do them from left to right, okay? There's no other inner parentheses or anything like that. Fine. So I'll just take these from left to right. Let me look at this cross multiplication. Now, here I'm projecting the names of the sailors that I know about. And here I'm projecting the names of the boat IDs that I know about, the rental IDs. Okay. Now, the result of this is going to be a list of all sailor boat pairs. Okay, so this is going to be a list where every single sailor is going to be paired with every single boat. Or equivalently, every single boat is going to be paired with every single sailor. And it's just going to be a big, long list of those. Here, this is a list of sailor boat pairs from the actual rental inventory, let's say. Okay. So in the purple, that's a list of sort of an imaginary world where every sailor rents every boat. Just like what are all of the combinations in that world? That's what you have in the purple. And then you're going to be subtracting from that the real world, which is the list of sailor boats pairs that you actually know about, of the sailors who have actually rented the boats. And so if you have a list of all the ways that any real sailor could have potentially rented a boat, and then you subtract away all of the actual rentals, what you're left with are like misses. Like these are now people. These are sailors who could have rented these boats but didn't. So you pick out somebody. Here's this sailor, Long John, and he could have rented, Shining Sea, but he didn't. And so, yeah, missed opportunities maybe. So here we're using that list of quote unquote missed opportunities to get the ones who weren't missed opportunities and who rented every single boat that we had, and now we're going to throw them a big party. But we can also take that same list of missed opportunities, and maybe we want that because we want to send out flyers or discounts, coupons or something for them. So yes, the sailor table only has SID and S name. The boat rentals table only has the RID and SID. How can I do a set difference? On the right here, I'm assuming you mean. Is somebody knocking or a woodpecker? Okay. How they don't have the same attributes? Well, let's look at that. So this sailor's here. It has a. Oh, sorry. SID. S name. Yeah, sorry, you're right. It should be SID. So, okay. Nothing I'm saying changes significantly. It's just, okay. So instead of, these are the names of sailors and the IDs of sailors who have rented a boat. Okay. For each boat that could be rented. I mean, I can't say this. Like, this is technically more accurate, but I feel like that now we're losing meaning by like, it's going to be harder to see the forest through the trees here. But yes, you're right here. For the this should be the SID. I will still say the way to think about this is matching a sailor with a particular boat. You can be more pedantic, but it will be no more clarifying. And now, of course, they should have the same attributes. Sailors has SID, S name here, And this is where the S name comes from, and then this is where the SID will come from. So S name, SID, S name, SID. Okay, so I guess if you have any more questions about this, you can hang out after class and ask. Before then, I really want to start getting into the next stuff, because we gotta start, yeah, moving on to like real world applications, and so that'll start kind of today. Oh, SQL grammar, I'm going to hold off on for a minute. Yeah. But now I would like to declare that we are done with relational algebra and background and foundations, and we are officially in the real databases section of the course. Okay. Now, this will be helpful for everybody who's in class. Can you just write in the chat the type of computer you're using? That is Mac, Linux, Windows, or something else. Oh, PC. Okay. All right. Wonderful. I'm so sorry, guys. Hang on just a second. We'll be right back. Okay. Sorry about that, guys. Good. All right. So, yes, seeing, wow, lots of Macs. Everybody's so into Mac. It's crazy to me. I'm Linux personally, but okay, great. So, let me start with a new page. Text interaction. Okay. So, youngins, are you? I don't know. I guess so. I don't know if you guys know like how your history of computers goes. If you've seen the movies from the 80s of, you know, people who not only had dial-up, but they'd have to like take their phone and put it on a thing. The War Games with Matthew Broderick, this kind of thing. And when computers first came out, there was no GUI. GUI, GUI, GUI is a graphical user interface. Which is how most people today think of computers. Would you be able to give us a quick computer history? I'll briefly be doing that now. I mean, like there's more to it. Like there's the 30s, 40s, 50s. Well, there's lots of computer history. This is the computer history of like the 80s, I guess. So, and if you haven't seen it, I mean, it's great. War Games. Um, Stars Matthew Broderick as a high schooler who's a hacker, computer hacker. Um, but not like for the government or anything. He's just, he's Matthew Broderick in the 80s, and he's just like, I don't know, a kid in suburbia with apparently really rich parents who can like buy computer stuff. And he's somehow both a slacker, but also very cool and really intelligent. In any case, War Games. So um, he'll like go in and like change his grades in the school system, and he by accident uh, gets involved in the Cold War, which is uh, maybe also relevant today for other reasons. Okay, back to computers. Now, one thing you might notice in a movie like War Games is that it's like green text. It's text. People have a computer, like a keyboard, and there's the monitor, and everything is text based. And that's what computers were uh, for a long time. I mean, decades. Since they hooked them up to a screen. Before then, there weren't screens. It was just punch cards and whatever. Then they had screens. Then everything was text. And that is the way that we're going to be learning about interacting with a computer is via a text terminal. It's the way that really the sort of modern computer age started with this type of format, and also it's caked into your computer, and it's the way that I'm not teaching it just for funsies. It's because it's a lot more practical and powerful, and after a little bit of a learning curve or a little bit of a hump, you'll be comfortable with it, and you'll have like new superpowers to impress your friends with. So everything was text based until well, now there were some games. You had your Atari and your Commodore. There were games, but games were graphical. But that was it. It was these like really Pong. These types of games, Pong, Tetris, um, these types of games, and then text. Text is the way that you would enter commands, navigate your computer, create files, um, all of this. Then there was a company called Xerox that made fax machines. And they were experimenting with having a graphical interface of their fax stuff. They had I should look up this history actually just to double check, but I'm pretty sure that Bill Gates like interned for them or did some contract work for them or something, saw this GUI interface, which was like a window, and there was a mouse, and you could click and drag a window, and like click a button and have a menu come down and stuff like this. And it was uh, the GUI interface. And Bill Gates stole it. Or maybe it was Steve Jobs. They were both going around that same time, just stealing everything from everywhere. I do know that the GUI came from Xerox. I'm pretty sure that that's what Bill Gates stole from them, but it might have been Steve Jobs. Steve Gates stole some. Well, anyway, lots of thievery and things. Okay, so one of the oldest operating systems is called Unix. Okay, it's a very, very old operating system that still exists today, kind of everywhere. I mean, it's ubiquitous. So Unix, there's some other sort of flavors like BSD that's not exactly Unix. But just to make things easy, I mean, this is, a business class. One of these turned into Mac OS, I'll say, and another turned into Linux. Okay, so if you have Mac OS, you're already running on top of Unix. That's not exactly true, but it's close enough to be true. Okay, for this class, it's fine. So for you Mac users, the operating system that you're using, Mac OS, is sort of like a layer built on top of Unix. Linux is also sort of like a layer on top of this operating system called Unix. So if you're familiar with Mac, you could shift to Linux very easily and vice versa. Fine. Now there's Windows as well, and Windows is its own thing. By the way, Unix, I mean, you also have here like Android. I mean, Android actually comes more from Linux, but, like, whatever. Linux is, more places than you'd imagine, like servers and things like this. Unix, in particular, is known for its stability. I mean, you can run for years and never have to restart. It's a pretty nice feature. Windows, as some of the users might know, it helps if you have a frequent restart schedule. Certainly, if you haven't restarted your computer in 6 months, might, I don't know, it'll be surprising. Okay. So back in like the 90s, I mean, this Unix has existed since like the 70s. It's been around forever. Windows has been around more since like the 80s, with DOS. I'll show a little tiny bit of that. Actually, it's not even DOS anymore. It's a weird Frankenstein crazy thing, but Windows is its own thing, which is why, for example, if you want to, I don't know, play games and things like this, Windows seems to kind of be the operating system for it. You can do a lot of stuff on Mac OS. It's gotten a lot better, but there's still certain applications, certain things that one operating system does better than the others, even till today. Now, Windows has something called PuTTY. And this is a like a Unix emulator. And for you Windows users, you can install this. It's a very small program. And basically what this does is it gives you a terminal, like a text box, like a window that you can enter text into to give commands that are like Linux commands, Unix commands. So this is traditionally what people would do for a long, long time. My suggestion would be to use the Linux subsystem for Windows. Okay. So Mac people, hang on. I'll be opening up a terminal in a minute and be on the same page with you guys. But for the Windows people, I want to explain very quickly why I'm giving this recommendation. So PuTTY was the only option forever because it's a different operating system unless you want to dual boot and turn off your computer in Windows and then boot up into like a Linux and then shut down and reboot and do all this. Your only choice was an emulator. And so there was an emulator program, like an emulator for, I don't know, old computer games and stuff. You know, it's like a program that runs a simple version of a system. And that's what PuTTY is. And it's still very common. It's probably, even today, what most people on Windows would be going to. However, it is still a program and an emulator. It's sort of, it's not the real deal. And some things are a little bit more laborious on it. And the things that you do with PuTTY don't transfer as well to other Unix systems. PuTTY is using Bash, that's right. Yeah, it's a Bash emulator. But Bash is a program that runs on a terminal, which is actually running on top of Linux or Unix. So, all of this is to say, why this is my suggestion is because it's like it's the real deal. This is not just like a small emulator. I mean, this is a virtual system for Linux. Like it installs actually Linux. And from inside of Windows, you can open up a window, and that's another operating system. I mean, it might as well be. Technically, it's not, but I mean, it might as well be. Like it's a virtual machine, so like if you run into issues and you need to Google assistance for things, commands will work. If you need to install another program in the terminal, you can do that with the Linux subsystem. For PuTTY, that can be more complicated. So, and it doesn't take long. If you Google, you know, Windows Linux subsystem installation, you'll find guides. It takes about 15 to 20 minutes. You have to download it. You have to enable some feature flag, reboot your computer and stuff. Okay. Now, just jargon. We have the word console. I was trying to think about these earlier. Console. Here you have terminal. You have command line. And here you have shell. Command prompt, maybe bash, ZSH, DOS. Okay. So, here are different words that you might hear, and people will also mix them up. That's if you're reading them online, if you're hearing somebody else speak of them, watching a video, people will kind of use these things interchangeably. But a console technically is a physical, like a physical screen and keyboard. Okay, so if you imagine going into a room with a bunch of servers, and you want to see what's happening on this server. So you plug in a monitor and you plug in a keyboard, and then that way you can see what's happening and you can interact with the computer. So then that computer would be said to have a console. So it's talking about the physical things. The terminal, or the command line, these are text input-output applications. And I'll be showing you a terminal in just a minute. And so that's just the name of the actual program. So when a window pops up and it takes text input and it can write text output, that is called a terminal. You have a terminal in Windows and in Mac. Now, that's just any input-output text thing. Now you can have specific ones, which is the shell. And this is the actual name of the program that's running. Some of these are they're specific shell programs. One of them is named Bash. That's probably the most popular one. ZSH is another popular one for Z shell. DOS, DOS, that's the one for old-fashioned Windows. And these are command interpreters. Okay, I'm going to try to share my whole screen if I can. Great. Okay. So I know we're ending class here, so I'm just going to move this quickly. This is an example of a terminal. Okay, so here it's just a text thing. You'll see a little blinking cursor, and then here you can input text. Okay, now this is in Windows that I'm in now, and there's certain commands that you can write. For example, if I write dir for a directory, it will print out the directories. You can see here, this is my home folder, C users Hobbs. That's where I'm currently located. And inside of my home folder and C users Hobbs, I have all of these different files and directories. Okay, so this is an example of one, a terminal, and two, a particular kind of shell. Okay, this shell understands, for example, dir. I'll do it again. Okay, this command, dir. It does not understand the command ls for list. That's because this is Windows, and the Windows shell doesn't understand this. But because I've installed the Linux subsystem, I can write bash, and now this will execute a different shell, still inside of the terminal, but now this is a different shell. You'll notice that the Windows shell had a $sign. Oh, actually, this one does too. But in any case, this one has C:/users Hobbs. So Windows users will know this is the C drive, users folder Hobbs. This will look more familiar to Mac users. This is the mount drive, the C users Hobbs. And now here, if I type ls, which was not understood in the Windows shell, it is understood in the Linux shell. Okay, or this is bash now. So I'm going to give you guys a couple of resources to start practicing some of these things on your own, and I'll pick up this on Wednesday. So have a good day.